Welcome to the complete CompTIA A plus 220-901 certification course. This single video combines all 4 chapters into one comprehensive study resource. Over 31 minutes of animated lessons covering 36 exam topics. We will walk through input devices, storage systems, motherboards, RAM, power supplies, cooling and complete network fundamentals. Each topic is explained with original animations and professional narration. Input devices and peripherals. In this chapter we will cover 9 essential input and output devices that you need to know for the CompTIA A plus exam. The keyboard, the mouse, the digital camera, the barcode reader, the scanner, the touch screen, the webcam, the media card reader and the docking station. Keyboard. A keyboard is the most basic input device on a computer, letting you type letters, numbers and symbols to enter commands. It is essential for everyday tasks like word processing, writing emails and browsing the web. Older keyboards used a round 6-pin DIN connector, which is largely obsolete today. Modern keyboards connect over USB instead, and many even include a DIN to USB adapter, so they can work with either type of port. Mouse. A mouse is a handheld pointing device that fits in your palm and mirrors your hand movement onto the screen as a cursor. It is used to launch programs, manage files, and navigate the web. Most Windows mice include at least 2 buttons along with a scroll wheel, while a classic Macintosh mouse traditionally came with just a single button. Digital camera. A digital camera captures photos and video and stores them electronically rather than on physical film like older cameras. Images are typically saved to an internal memory chip or a removable SD card. Once captured, you can transfer those images to a computer using a USB cable or by removing the SD card and reading it directly. After transferring, the photos can be viewed, edited or printed. Barcode reader. A barcode reader scans printed barcodes using a beam of light and converts that pattern into usable data. It is commonly found at retail checkout counters and in inventory management systems. These devices can connect through a serial port, a USB port or even wirelessly. While barcode readers come in a few different shapes, the handheld trigger style is by far the most common form you will encounter. Scanner. A scanner lets you create a digital copy of a physical document or photograph. Most scanners use a flatbed design. You place the item face down on the glass, and as the scan head sweeps across it, the image is saved to your computer. Scanners are available as standalone devices or combined with a printer in a single all-in-one machine. Touch screen. A touch screen is essentially an LCD display with a touch sensing layer built on top. It detects the position of your finger the same way a mouse detects a click. One tap acts like a single mouse click and 2 quick taps act like a double click. You will find touchscreen technology in tablets such as the iPad, in many all-in-one desktop computers and on most modern smartphones. Webcam. A webcam captures live video and most models also include a built-in microphone to capture audio at the same time. They are most often used for video calling and conferencing, connecting over a USB cable to the computer. Applications like Skype rely heavily on webcams for face-to-face communication online, and 2 of the most recognized webcam manufacturers are Logitech and Microsoft. Media card reader. A media card reader gives a computer the ability to read memory cards from devices like digital cameras. It is a small device, usually connected by USB, with multiple slots sized for different card formats such as micro SD and mini SD. Once a card is inserted, its data can be read and transferred directly onto the computer. Docking station. A docking station turns a laptop into a full desktop setup in seconds. Instead of plugging in a separate monitor, keyboard, mouse and printer, every time all of those peripherals stay connected to the dock itself. You simply set your laptop into the docking station and everything connects automatically. The one thing to remember is that docking stations are proprietary, built for a specific laptop model, so there is no universal one-size-fits-all docking station. Chapter 2: KVM switches, smart devices, displays and printers. In this chapter we will cover KVM switches, smart TVs, smart cards, biometric devices, display types and resolutions, inkjet printers, laser printers, printer maintenance and virtual printing. KVM switch. KVM stands for keyboard, video and mouse. A KVM switch is a device that lets you control multiple computers from a single keyboard, monitor, and mouse. Each computer has its own dedicated cable to the switch. You press a button to select which computer to control. Basic models handle 2 computers while higher end units can handle 8. KVM switches save money and disk space by eliminating the need for a separate display and input set per machine. Smart TV. A smart TV is a TV that connects to the internet, combining a standard TV with computer-like capabilities. Beyond watching regular broadcasts, you can browse the web, stream movies and shows from services like Netflix, and video chat using applications like Skype. Many smart TVs include a built-in webcam and microphone for video messaging. Essentially, a smart TV delivers the full internet experience on a large living room screen. Smart card. A smart card is a security device used to verify a person's identity. It is the same size as a standard credit card and contains an embedded microprocessor chip that stores encrypted identity data. To authenticate, you insert the card into a smart card reader, which reads the chip and confirms the user's identity. Smart cards are considered secure because the physical card must be present. You cannot log in without having it on you. Biometric device proves a person's identity by reading unique physical characteristics. The most common example is a fingerprint scanner. You swipe your finger across the sensor and the scanner either grants or denies access based on whether the fingerprint matches the stored record. Today, fingerprint scanners are built directly into many laptops and smartphones. Other biometric methods include iris scanning and facial recognition. Display types. Modern monitors use liquid crystal display technology. The most common type is TFT, which stands for thin film transistor. TFT gives every individual pixel its own transistor, producing a sharper and more responsive image. A second type you need for the exam is TN, which stands for twisted nematic. TN panels work by twisting light through liquid crystals. They are older and more affordable with fast response times, but suffer from narrower viewing angles compared to newer panel technologies. Display resolutions. Resolution describes how many pixels a monitor can display, written as width by height. Key resolutions to know: SXGA is 1228 by 1224, SXGA Plus is 1400 by 1250, UXGA is 1600 by 1200, and WUXGA is 1920 by 1200. Higher resolution means more pixels and a sharper image. Also remember the contrast ratio. This measures the difference between the darkest black and brightest white. A display can produce a higher contrast ratio, gives richer and more vivid images. Inkjet printer. An inkjet printer creates images by spraying tiny droplets of liquid ink onto paper. The droplets are smaller than a human hair, and their precise placement produces high quality output, including photo quality prints. A typical inkjet uses 2 cartridges, one for black ink and one for color. Inkjet printers are more affordable upfront than laser printers and produce excellent photo results. However, one drawback is that the ink can smudge if the page is touched before fully drying. Laser printer. A laser printer uses a laser beam to draw an image onto a light sensitive drum. Toner powder sticks to the charged areas and transfers to the paper, where a fuser unit bonds it permanently using heat and pressure. Because the toner is heat fused, laser prints never smudge. Laser printers are faster than inkjet printers and produce crisper text, making them the preferred choice in office environments. The cost per page is typically lower than inkjet over time. Printer maintenance. Regular maintenance keeps a printer running reliably. A common problem is paper jamming or coming out creased. This is often caused by debris inside the printer or by worn out pickup rollers. Pickup rollers are rubber rollers that grab each sheet and feed it through. As they wear out over time, they lose grip and struggle to feed paper correctly. You should inspect the rollers for wear and replace them if needed, and always check inside for torn paper or debris. Virtual printing. Virtual printing means printing to a digital file rather than to physical paper. The most common format is PDF, portable document format. When you print to PDF, you get a file that looks exactly like the printed page. PDF files can be emailed, transferred by flash drive, or shared online. Because PDF is a universal format, virtually every modern device can open one without any extra software. Older devices may require Adobe Acrobat Reader, which is available as a free download. Storage and motherboards. In this chapter, we will cover hard disk drives, SATA interfaces and solid state drives, removable and optical storage, motherboard form factors including ATX and Mini ITX, PCI and PCI Express expansion slots, and Intel and AMD processor socket types. Hard disk drive. A computer has two types of memory: primary memory, which is temporary, and secondary memory, which is permanent. The hard disk drive is the most common form of secondary storage. It is a sealed unit containing magnetic platters that spin at high speeds. An actuator arm moves across the platters to read and write data. Hard drives spin at 5000, 400, 7200, or 10,000 RPM. Most desktop computers use 7200 RPM drives. Laptop hard drives typically run at the slower 5400 RPM. Hard drives are non-volatile, meaning they retain all stored data even when the power is off. Storage interfaces and solid-state drives. Modern hard drives use the serial ATA interface, also known as SATA. SATA replaced the older parallel ATA standard. Unlike parallel connections that send data across many wires at once, SATA sends data one bit at a time, reaching transfer speeds of up to 6 gigabits per second. SATA cables are much smaller, making cable management easier, and the drives are hot swappable. A solid-state drive, or SSD, stores data using flash memory chips with no moving parts, making it extremely fast and durable. Hybrid drives combine spinning platters with a flash memory cache, offering a middle ground between cost and performance. Removable and optical storage. Removable storage devices connect externally and are easy to transport. A tape drive is an affordable backup solution that connects via USB and writes data sequentially to magnetic tape. DVD is a widely used optical disc format. A standard DVD holds 4.7 gigabytes of data. Dual-layer DVDs add a second recordable layer, increasing capacity to 8.5 gigabytes. Blu-ray is the newest optical format, released in 2006. It uses a shorter wavelength laser than DVD, allowing much greater data density. A single-layer Blu-ray disc holds 50 gigabytes and a dual-layer disc holds 50 gigabytes. Motherboard form factors. The motherboard is the main printed circuit board of a computer. It connects the CPU, RAM, storage and all other components, allowing them to communicate. Motherboards come in standardized sizes called form factors. The most common is ATX, which stands for Advanced Technology Extended. Created by Intel in 1995, a standard ATX board measures 12 by 9.6 inches and uses a 24-pin main power connector. Micro ATX is a smaller version at 9.6 by 9.6 inches, and it shares the same mounting holes and power connectors as ATX, so it fits inside a standard ATX case. Mini ITX is the smallest at 6.7 by 6.7 inches, designed for compact low-power systems. Expansion slots. Motherboards include expansion slots for installing adapter cards, such as graphics cards, sound cards, and network cards. The older standard is PCI, Peripheral Component Interconnect. PCI slots are 32-bit, operate at 33 MHz, and deliver a maximum transfer rate of 133 megabytes per second. PCI uses a parallel bus, sending data across multiple wires simultaneously. PCI has been replaced by PCI Express or PCIe. PCIe uses a serial bus with dedicated point-to-point lanes, making it significantly faster. PCIe slots come in 4 sizes based on the number of lanes: X1, X4, X8, and X16. The X16 slot is the largest and is used primarily for graphics cards. A smaller card can be installed into a larger slot using what is called up-plugging. Processor sockets. The CPU socket on the motherboard holds the processor and connects it to the electrical circuit. There are two main socket designs you need to know. Intel primarily uses LGA, which stands for Land Grid Array. With LGA, the contact pins are located inside the socket on the motherboard, while the bottom of the processor has flat gold contact pads. This protects the CPU from pin damage during installation. Common Intel LGA sockets include LGA 1150, LGA 1151, and LGA 2011. AMD uses PGA, which stands for Pin Grid Array. With PGA, the pins are on the processor itself, and they drop into small holes in the motherboard socket. AMD uses a zero insertion force lever to lock the processor in place. Common AMD sockets include AM3, AM3 Plus and FM2 Plus. Chapter 4: RAM, Power, Cooling and Networking. This is the final chapter of the course. We will cover RAM types and DDR standards, power supply units, cooling systems, custom PC configurations, network cables, core network devices, IP addressing, fundamental protocols and ports, and network command line tools. Computer memory and RAM types. RAM stands for Random Access Memory and is the primary memory of a computer. Unlike a hard drive, RAM is volatile. It loses all stored data the moment power is removed. The standard type used today is SDRAM, which synchronizes with the processor clock. Modern RAM follows the DDR standard, which stands for double data rate. DDR transfers data on both the rising and falling edges of the clock cycle, effectively doubling throughput. DDR2 reduced voltage to 1.8 volts. DDR3 dropped further to 1.5 volts with higher speeds. DDR4 lowered voltage to 1.2 volts while delivering the fastest transfer rates. Yet desktop computers use full-size DIMMs while laptops and compact devices use the smaller SODIMMs. Power supply unit. The PSU converts AC power from the wall outlet into the DC voltages that computer components require. A PSU supplies several voltage rails. The plus 3.3 volt and plus 5 volt rails power the motherboard and legacy components. The plus 12 volt rail is the most important in modern systems. It powers the CPU and the graphics card. The main motherboard connector is a 24-pin plug. The CPU receives dedicated power through a 4 or 8-pin connector. High-end graphics cards need a 6 or 8-pin PCIe power connector. SATA power connector supplies storage drives, while older Molex connectors power legacy fans and peripherals. When choosing a PSU, total your component power draw and add headroom. The 80+ certification rates efficiency from white at the lowest level up to titanium at the highest. Cooling systems. Computers generate significant heat during operation and need cooling to stay stable. The most common solution is air cooling. A heat sink is a block of aluminum or copper placed directly on the CPU, drawing heat away from it. Thermal paste fills microscopic gaps between the CPU and heatsink to improve heat transfer. A fan mounted on the heatsink forces air through its fins to dissipate the heat. For high performance systems, liquid cooling provides superior thermal management. A water block mounts on the CPU and liquid coolant absorbs the heat. A pump circulates the hot liquid to a radiator, where fans cool it back down before it returns to the CPU. All-in-one liquid coolers are a popular and easy to install option for enthusiast builds. Custom PC configurations. Different workloads require different hardware priorities. A gaming PC needs a high-end dedicated GPU, a fast multi-core CPU, high-speed low-latency RAM, and robust cooling. An audio and video editing workstation requires a professional-grade video card, a minimum of 32 GB of RAM, a fast SSD for active projects, and a large hard drive for archiving. A virtualization workstation must run multiple operating systems simultaneously, so it demands maximum CPU cores and threads plus as much RAM as possible, since each virtual machine needs dedicated hardware resources. A thin client is the opposite, a low-power device that relies on a central network server for processing, requiring very little local storage or graphics capability. Network cables and connectors. Twisted pair cables are the standard for local area networks. UTP or unshielded twisted pair is the most common and affordable type. STP or shielded twisted pair wraps the wire pairs in a foil shield to block electromagnetic interference. Cable categories define performance levels. Category 5 supports up to 100 megabits per second. Category 5E adds tighter twists to reduce crosstalk and reaches 1 gigabit per second over 100 meters. Category 6 supports up to 10 gigabits per second for distances up to 55 meters. Fiber optic cables transmit data as pulses of light. Single mode fiber uses a laser and supports very long distances. Multi-mode fiber uses LEDs and is designed for shorter runs such as within a building or server room. Core network devices. A hub is the most basic network device. It blindly broadcasts every incoming data packet to every port on the device, creating unnecessary traffic and slowing the network. A switch is far more intelligent. It reads the MAC address of each connected device and forwards data only to the specific port of the intended recipient, improving both speed and security. A router connects different networks together. It reads IP addresses to route packets between your local network and the internet. A modem, short for modulator demodulator, converts the analog signal from a cable or DSL line into a digital signal that your router can understand and process. Addressing and subnetting. Every device on a network requires a unique IP address. An IPv4 address is a 32-bit number written as four groups of digits separated by dots. For example, 192.168.11. Each group is called an octet and can range from 0 to 255. The subnet mask defines which part of the address belongs to the network and which part identifies the individual host device. A common subnet mask is 255.255.0, meaning the first three octets identify the network and the last identifies the device. IP addresses can be static, meaning manually assigned, which is common for servers and printers, or they can be dynamic, automatically assigned by a DHCP server each time a device connects. Fundamental protocols and ports. Every network service operates on a specific port number. HTTP runs on port 80 and handles unencrypted web traffic. HTTPS runs on port 443 and encrypts web traffic using SSL and TLS. FTP uses ports 20 and 21 for transferring files between systems. SSH operates on port 22 and provides encrypted remote access to systems. DNS runs on port 53 and translates human readable domain names like google.com into numeric IP addresses that routers can use. Memorizing these port numbers is essential for the CompTIA A+ exam and for daily network troubleshooting work. Network command line tools. These tools are essential for diagnosing network issues. The ping command tests basic connectivity by sending ICMP echo requests to an IP address or website and reports whether responses are received and how long they take. The traceat command traces the full route a packet takes to its destination, listing every router hop along the way. The ipconfig command displays your current IP address, subnet mask, and default gateway. The netstat command shows all active network connections on your system, and the nslookup command lets you manually query DNS to look up the IP address associated with any domain name. Congratulations on completing the full CompTIA A+ 220-901 certification course. You have covered all 36 topics across 4 chapters, from keyboards and peripherals all the way through to network protocols and command line troubleshooting tools. Keep reviewing the topics you found challenging, practice hands-on wherever you can, and you will be well prepared for the exam. Thank you for studying with us and good luck on your CompTIA A+ certification.